All right. So where we were is we just got introduced to this command line interface, and we learned that there are various modes, etc. Now we are going to get into a very important topic called IP routing. IP routing. IP routing. Everything in the internet comes under IP. Whether it is ping or telnet or SSH or file transfer or mail, voice, everything comes under IP only. All protocol works under IP. We are in IP network. In that IP, we have TCP, UDP. In that IP, some application uses TCP, some application uses UDP. For example, Telnet uses TCP. We are going to learn a protocol called RIP that uses UDP. But if IP is not there, there is no TCP, there is no UDP, there is nothing. So when we say IP routing, this path that we provide for IP path, that's for routing. That is what we call as routing, providing path information. Providing path information for what? For the IP packets to go. IP packets, if it wants to go from this network to that network, there is need for a path. Providing the path is what called as routing. Now, routing the IP packet which means that it includes everything in networking. Providing IP path for telnet, SSH, anything in networking, you name it.
What you're seeing,
that's what called as IP network. IP network means every application in network, and they all need path, and providing path is what called as IP routing. For example, let's say we have a computer. We got a computer here, and that computer is in 10 network. Now I got another computer in same 10 network. In this case, the packet can go from here to here using switch. There is no need for routing because this is not between two different networks. See, this is IP address. This is also IP address. Because they are in same network, you don't see a router in between. There is no one needed to route packet between these two devices because they both belong to same network. Only when we are having a different network, we need a router. When they are in different network, only then we need a router. Same network, no need a router. Now let's say we have here 20. 20002. So definitely there is need for IP routing. From this IP, someone should show the path to go to this network and this IP. Someone need to show the path. That is why we call it as router. It routes. It shows the route. Router. So usually router we put one circle and we draw like this. This is what we call as router. Now router is to route the packet from one network to another. To route the packet. When a packet arrives from A, the packet wants to go to B, which means the packet source address is 10.0.0.1 and destination is 20.0.0.2. When this packet arrives, the router should show the path. Router should say, you want to go to 20. Now you just go this way out. The router should inform. The router should tell the controller that the packet should be placed in this port. Let me call it as G2. Packet enters in G1 and there is a routing table in the router which will say connected a network 10 on G1, connected another network 20 on G2. So we will see the network of the IP address that we have put here. When you put the IP address 10.0.0, let's say 10.0.0.10 here. Here when you say 20.0.0.10 here. As soon as you put this IP and say no shutdown on the port, this will come immediately, automatically, dynamically. These routes will come into the routing table dynamically. Now, we give the PC the router's address as the gateway. So what is the gateway of computer A? 10.0.0.10. What is the gateway of PCB? 20.0.0.10. So when you do that, what happens? The PC cannot route the packet to 20 because the PC is in 10 network. So what PC will do, it will push the packet to this address. But it won't change the IP address of the packet. IP address of the packet will be same. But what it does is, it puts the MAC address. Let's say the MAC address of this is AAA. So what does it do? PC will put its own MAC address as source and destination MAC address as BBBB. Why it is putting BBBB MAC address? Because that is the MAC address of the gateway. If I move the packet to the gateway, gateway will move the packet to 20 network. So I am going to put what? The MAC address of the gateway. This is how the PCs use the gateway address. They learn the MAC address of 10.0.0.10 by using ARP, Address Resolution Protocol. By using ARP, ARP will do layer 2 broadcast and learn the MAC address of 10.0.0.10. So once the MAC address of the gateway is learned, that MAC address is placed in the destination field in layer 2 and the packet is now sent to the router. Now router, on receiving the packet, First, it will check to which destination the packet belong to which destination the packet need to go. It is 20002. So router will check whether I know about 20 or not. Yes, I know about 20. 20 is in which interface? G1, G2. So what it will do now, the router, it will give control saying the packet needs to exit on this port. Now what we'll do, the routed protocol, see this is the routing. But there is a layer 2 protocol called routed protocol, called Ethernet protocol. Ethernet. What the Ethernet will do now on the router, what it will do, it will have these things, no change, source MAC address, it will put this MAC address, CCCC. And the destination MAC address, by using ARP, it learns the MAC address of B and puts the MAC address of B. And pushes the packet out on G2, and the packet comes and gets delivered here. You see, we can see here the router informs the layer 2 controller via which port it should send. Accordingly, via which port it should send the packet. Accordingly, this routed protocol, the Ethernet, it changes the MAC address and it sends the packet out on G2. Without routing, this is not possible. So, routing table is referred. When a packet wants to go to different network, the packet comes to the router, and the router checks the routing table and knows the exit interface. After knowing the exit interface, it puts the exit interface MAC address as the source MAC address, and the original destination MAC address as destination MAC address. By using ARP, it learns it and delivers the packet to B. This is simple routing. Now, let's make it a little bit bigger. We'll take switch, another switch, and a router, another router, another switch. We got router 1, router 2, 10.00.10 G1 and 20.00.10 let's make it G2 20.00.10 and G3 30.00.10 30.00.11 and 400010 G1 G2. We got a computer. This computer IP is 10001. This is 20001, and this is 40001. So what is the gateway on this 40 PC?
40 PC for 400010.
400010, 200010, 100010. Now this is switch 1, switch 2, switch 3. Okay. Now take some MAC addresses. It's not important. Now we are getting into the other side of IP routing, so I'm not writing MAC address. Now we will have a routing table here, and also in this router we'll have routing table. In router 2, I'll have route to reach 40. On which interface? G1. And 30. On which interface? G2. Yeah? Because you have G1, G2 this IP address, G1 this IP address. And in router 1, 10 network on G1, 20 network on G2, 30 network on G3. So router 1 do not know about 40 because it is not connected directly. Likewise, router 2 do not know about, tell me.
Router 2 do not know about the 40.
Router 2 knows about 40. It is directly connected, no?
No, okay, yeah. Router 2 do not know about 10.
10 and then? Only 10?
10 and 20.
Ah. It do not know about 10 and 20. It knows only the directly connected. It knows 30. It knows 30. It knows 30. It knows 40. It do not know about 10 and 20. As a result, we will not be able to ping from A to C. We can ping from A to B because the A and B networks are there in router 1 routing table. A can ping B, B can ping A, no problem. That's what we saw in the previous example, right? Same router. But can C ping B? No. Can C ping B? No.
No.
Why? The packet for 20 network will come to the router and it will check the routing table for 20 destination. And the routing table will reply. Router will reply saying, reply from 10.00.10, reply from 40.00.10, destination, host, unreachable. This message will come. When you ping from C, 20.001, when you ping that address, the packet will go up to router 2. From C, it will go to router 2 because you have a gateway, no? It will go to router 2. Because router 2 do not know about 20 in the destination, router 2 will reply back. You will see the reply and see destination host unreachable. Shall we do up to this level and see?
Yeah.
Okay, let's do this. You see, we can use Ethernet cable to connect, or you can also use serial cable to connect if you have a serial port. Usually the WAN ports are called as serial ports. Where serial ports are also called as WAN ports. What do I mean by that? You see, it looks like more number of you see, this is serial port. This one here, which I am showing here. Here, look at this. No, I'm showing you. See my hand that moving there. You see serial 0, serial 1. You see? This is new type. This is old type. Old type will be like 52 holes will be there. 52 holes. Tiny, tiny holes. Let me try to open this. You see? See small, tiny, tiny ports? Okay. Now, whereas the Ethernet ports will be like this, but this is not Ethernet port. They don't have Ethernet port in this picture. Let me show you. Fast Ethernet ports, you know it. You know it. These are all fast Ethernet ports. Okay, so in our topology here, we have one serial port connecting this to router. Because I don't have an Ethernet port there, I just got 2 gig Ethernet ports I already used in switch A, router A. I already used in router A 2 ports. So we have another port serial port to connect to the other switch. I connected this port. So how do we get the serial port? If you go to this physical and then drag and drop this 2T here. Before that you have to switch off. Before that you have to switch off the router and do it. Alright. What is next? I'm going to connect some computers. 1, 2, 3. And to this computer, the IP address that I'm going to give is 10.0.0.1/8, and the gateway is going to be 10.0.0.10, which means 10.0.0.10 is the IP address on G0.0.0 of router. Correct? All this I'm doing only for your reference. When you do, you just do it on the command line. You no need to do like these things on the white screen. You no need to do it. Right, we will connect the wires between the switch and the PC. Done. This is going to be 40.0.0.1/8 hyphen 400010. Okay, so what I'm going to do, first I'll finish this computers. The IP here will be 10.0.0.1, 10.0.0.10. To verify, we go to command line, command prompt and say IP config. We can see our IP address are already taken. And here 20.0.0.1, 20.0.0.10. Likewise, another last computer.
Forty. 40.
Yeah. All right, verify. Now let us go to the router and put the IP address. Enable config T hostname router A. The interface IP address is G000. First bring it up and then put the IP address. See, the mask is very important. And I have said no shutdown, right? You can also do late after. If you forget to give no shutdown, no problem in the beginning, but you have to do it in some point of time before you test, okay? See, what I'm trying to say is there is no sequence. There is nothing like you have to do that fast and then only you can put IP address. No, not like that. There is no order. All right, next.
So switch automatically came up. So there is no need for no shutdown.
Correct. All the switch ports are up by default. For security reason, only on this WAN device router, we have to say no shutdown because for security they have shut it down. Next. What is the other interface we have?
Serial.
Yeah. You need to exactly type that number. Interface serial 0/1/0. 30.0.10. That is all. This interface won't come up fully, only it administratively comes up. The line protocol will not come up until you go and say no shutdown on the other side. You understood that, right? Unless you go to the other side and say no shutdown, this is not going to come. So,
So IP interface.
okay, I'm going to show you. You see? Show IP interface brief command. You can see that this is down because the other side is down. But here this is both up. Here both are up. Now moving on to the next router. Am I right?
Okay.
40.0.0.10. All right. We have finished giving IP address, right?
Yeah.
You see the interfaces are up on both the routers.
Okay.
Even here you should see all up. Yeah, it's up. Now, as I was telling you, if you ping from this PC to this PC, the ping will go because both the networks are in same router. Ping 20001, the ping will happen. One or two packets will be lost because of ARP. Now you see it's pinging. See, you are pinging 20001, you are getting reply from 20001. But when I ping from here, 20001, who is replying me? It's not 20001 replying me. It is my gateway. This is gateway replying me. 40.0.0.10 is gateway, no? That gateway says the destination is unreachable. You know that, right? When you check the routing table also, you can see that. You see, it knows only about 40 and 30. There is no route for 10 and 20. You understood?
Yes.
Up to this much only we have covered in theory. Yeah? Okay. How do we ping between 40.0.0.1 and 20.0.0.1? With the help of static route or with the help of a dynamic routing protocol, we can ping. Either this or that. If you want to have both, you can have. So, we need to tell the router the path. We need to tell the router, let's say router B, the one which is in the left hand side, no? Sorry, right hand side. We need to tell that router, you send the packet to 30.0.0.10. How do we do that? Let me show you. I go to this router and this router B, show IP route. It do not know about 10 network and 20 network. So what I'm going to say is I'm going to say, hey, if you have any IP packet, route the IP packet that want to go to 20 network to the next router. What is the next router's IP? You understand? This is the IP address of router A, correct? And this router knows 30. It knows that I need to send it via serial 1/0. You understand? It will send this way. And also I should say route any packet that wants to go to 10 network to 30.0.0.10. You understood? We are asking this router to send it to the next router. After writing this, check the routing table. Show IP route. You see, we have statically written. S means what? Static. C means what? We have two routes statically written saying need to be forwarded to this address, this router. Fine. What is next? If you will go to router A, there also a network is missing. What is that? Correct. So here we are going to say IP route Any packet to 40 network, if it comes, send it to 300011.
Okay.
You agree?
Yeah.
300011 knows about 40 network. Correct now?
Yeah.
It knows about 40 network. After writing this, you can ping from anywhere to anywhere. How many networks are there in this topology? How many networks are there in this topology? Tell me.
2 networks.
Please count properly. How many networks?
2 routers, 2 networks. Sorry, 3. 4 networks.
4 networks are there. Which means each router should have 4 network in the routing table. Show IP route. Do you have 4 network? Do you have 4 network?
3.
3 connected. One more is there, no? Static.
Yeah. Yeah, there is
So we have totally 4 network, right?
4 networks. Yeah.
And also on the other router you should have 4 network. 10, 20, 30 and 40. Which means I can ping from any network to any network. I can go to here and ping 30, 3011. 3011 is who? The router. And then I can also ping 40001. You see? I'm able to ping 40001 also.
So, what is the syntax for IP route? The IP route?
Static route, no? For static route. What is the syntax for static route? IP space route and the destination that you do not know which you want to write, and then the gateway to which you need to send. This is the gateway for this network, correct? For 40 network, router B is the gateway. Gateway for 40 network. The next router is the gateway for this router, correct?
That's I'm confused actually. 30.0.10. What is 11?
No, you have to give the IP address of gateway, not your own. 10 is your own. Very nice.
So, this is called static.
Correct. Right? So I want you to do a lab, same topology. I will take a snapshot and give you. Do a lab and then give me your feedbacks.